In this video, we'll be looking at the isUnique interview question in Java. My name is Larry, and this is Digital Logic. To get started, you'll need to download the project from GitHub. The link is in the description below. I've also provided a link to the introduction video to the series, which will walk you through setting up your development environment. With that out of the way, let's get started. So I've already got the project open in IntelliJ. So I'll open the project browser and find the isUnique class. For this challenge, you need to write a function that will determine if a string contains only unique characters. That is, a character can only appear once within the string. Once you have a solution that you're ready to test, you can press Ctrl+Shift+T to open up the testing class. Then click on the little icon next to the class name to run the test. The testing class will pick up any public method that you define that matches the expected signature, so you can provide multiple solutions, and the testing class will test all of them. So go ahead and pause the video now and try to come up with a solution to this challenge. When you're ready to continue, come back here and we'll walk through a couple different solutions. Welcome back. So I'll start by renaming this method to sorted, and then delete the return false statement. So one possible solution to this challenge would be to sort the characters within the string. Then we'd only have to compare each character with the next character in the string. If they're equal, return false. Create a new string array equals str.toLowerCase.split, and then pass in an empty string. This will have the effect of splitting the string into an array of single character strings. Now we need to sort the array, so use the arrays.sort method and then pass in the string array. Now create a for loop to iterate through each item within the array. Set the execution condition to while I is less than the string array.length -1, and then increment I. Now check if the string array at position I is equal to the string array at position I plus 1. If this statement is true, return false. If we make it through the for loop without ever returning false, then return true. Press Shift F10 to open up the testing class, and then run the test. The solution has passed the test. So the solution does work, but it isn't the most efficient, and the reason is because we have to sort the array before we can start iterating through each element in the array. In the next solution, we'll use an IntArray to keep track of the character count. And I'll start by creating a new public static method named IntArray. And then create a new IntArray char_map equals new IntArray and set its length to 26. I'm setting the length to 26 because there are 26 letters in the alphabet, and each index in the char_map will refer to a single letter in the alphabet. Create a for loop to iterate through each character in the string. Make sure to call toLowerCase, followed by toCharArray. Now we need to increment the counter in the char_map for the current character, C. So char_map at C minus the character A, and then increment this integer. Subtracting the character A from C will create an offset so that the letter A will be stored at index 0 within the char_map, B will be stored at index 1, and C will be stored at index 2, and so on. Now we just need to check if any of the integers in the char_map contain a value that's greater than 1. We could have done this in the previous for loop, but I chose to separate it out. So I'll create a new for loop, init I in char_map, and then if I is greater than 1, return false. And then if we make it through this for loop without ever returning false, return true. Press Shift F10 to rerun the test, and it passes. So in this solution, we used an IntArray to maintain the character count for each letter in the string. In the next solution, we'll use a HashMap to maintain this count. So create a new public static method and name it HashMap. And then define a new map of type string and integer named char map equals str dot to lowercase dot split, and then pass it an empty string, and then convert the array into a stream using the arrays.stream method. And now call collect, followed by the collectors.toMap function. For this function, we're going to pass in 3 parameters. The first one is the key mapper, and it defines how we retrieve the key from the stream. The second parameter is the value mapper, and in this case, we're just going to define that each key will have the value of 1. The third and final parameter is the merge function, and it defines how we merge the values from 2 keys that are equal. In this case, all we need to do is sum their value. The char map now has an accurate tally for every character in the string. We just need to find out if any of the entries in the char map have a value larger than 1. So I'll return char map.values.stream and then call filter. The filter condition will be while I is greater than 1. And then call findAny. FindAny is a short-circuiting terminal operator that returns an optional. What does that mean? The first value that makes it to findAny will terminate the execution of the stream and give us an optional, at which point we need to call isEmpty to find out if there's a value in this optional. Press Shift F10 to rerun the test, and it passes. So far, none of the solutions that we've covered can solve this problem without requiring an extra data structure. In this next solution, I'll demonstrate how you can solve this problem without an extra data structure while still maintaining linear time complexity. So I'll start by defining a new function, and I'll name it ExtraCredit. Now, I don't care how many times any one character appears within a string. I only care if a single character appears more than once. So we don't need to maintain a count. We just need to know which characters have appeared and which haven't. So we could solve this problem using an array of booleans. And it would be very similar to how we solved it using the array of integers. But an array of booleans would still break our no extra data structures rule. So what could we do instead? A single integer contains 32 bits of data. And through bit manipulation, we can use a single integer to act as our Boolean array. So I'll start by creating a new init bit mask and set it equal to 0. Now create a for loop to iterate through each character in the string. This could be an enhanced for loop. It really doesn't matter. I'll just stick with the traditional for loop for this example. Next, create an init val equals str.charet I minus the character a. This will be the index in our bit mask where we store the Boolean value. Now we need to check if this position has already been flipped in the bit mask. So I'll create a new if statement, bit mask, and 1 right binary shift val. So I need to add some more parentheses first, but I want to make sure that this expression is not equal to 0. So first we're taking the binary value of 1 and shifting it over to the right in places, and then performing a binary AND against the bit mask. What this will do is 0 out all other positions in the bit mask except for this 1. And then we just need to check if the result of this operation is a non-zero value. If it is non-zero, that means that we've already encountered this letter before and we need to return false. If we make it through this if statement, then we need to flip the bit at this position within our bit mask. And to do that, we need to OR it in. So bit mask pipe equals, and this is just like the plus equals operator. Then we take our binary 1 and shift it over in places, and then ORing it against the bit mask. and then taking the resulting value and assigning it back to the bit mask. And then if we make it through this for loop without ever returning false, then every character in the string is unique, so return true. Then press Shift F10 to rerun the test, and it passes. Some of you may have noticed that I did not call to lowercase within the solution. Some of the test cases do include capitalized letters, so why is this solution still passing the test? The reason is because the capital letter and the lowercase letter are exactly 32 digits apart. This is true for the ASCII code character chart as well as the Latin Unicode chart. When shifting an integer, the shift operator applies the value 31 as a binary mask to any value that you provide it. Because of this mask, a capital letter and a lowercase letter ends up getting the same index. You can verify this yourself. Just keep in mind that when you provide a negative number to the shift operator, that you need to take the binary version of that negative number in 2's complement, then apply the 31 value as a binary mask, and then you'll get the shift distance. Anyway, that is it for this video. If you like this video, then please like, share, subscribe. If you want to support the creation of these videos, then check out my Patreon page. A link is in the description below, and I'll see you in the next video.